Hey robot makers, I hope you're having a good day so far. So do you want to learn about the Arduino Cloud and how to build an Internet of Things? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get straight to it, shall we? So yes, this is a bit of a break from the Raspberry Pi 5 fest that has been over the past couple of weeks, and I thought we'd look at the Arduino. There's a good reason for that as well. So today we're going to look at the Arduino Cloud and how we can use this with the ESP32 from Arduino. They have a new Arduino that's, I think it only came out in the last month or so. So we've got one of those, so we're going to have a play with it today. So we're going to create some things that you can use with the Arduino Cloud. So there's several different parts to this. There's the devices, the things, the dashboards, and the integrations. So we're going to have a look at each of these one at a time and then build live on stream an Internet of Things thing. And then if you're here for the live stream show, we'll do a bit of a mailbox and Q&A. There's quite a lot of stuff to show you today as well, so it's quite cool. Okay, let's get to it, shall we? So yes, when I was in the Maker Faire in Rome this year, one of the reasons I've been offline for the past 2 or 3 weeks, I went to the Rome Maker Faire, just outside of Rome, at the Fiera di Roma, and I met Massimo, who's the inventor, creator of the, or co-creator of the original Arduino. One of the very first projects I did with robotics was with, I think actually this Arduino I got from Maplins back in the day when Maplins used to be a thing. So this was my original Arduino Uno. It's an official Arduino, not one of the cheaper knockoffs. And the idea with that is you're actually supporting the Arduino Foundation and all the stuff that they do there. So you pay quite a bit more than one of the sort of knockoff versions, but it's open source hardware, so they do welcome that. So yeah, it's great to sort of meet Massimo in person and say hi and do a crazy selfie like this. So what is the Internet of Things and how does the Arduino Cloud fit into this? So an Internet of Things, it was a bit of a buzzword a couple of years ago when microcontrollers became really popular, and Arduino was one of the first to do that. And with the popularity of Wi-Fi in home networks, that meant that you could now build your own contraptions, your own things, as it were, that can connect to either your local area network and your local infrastructure, your local servers and things, Raspberry Pis and so on, or a cloud-based service such as the Arduino Cloud, or for example, Adafruit have a cloud as well of their own. Is it Adafruit IO? I can't remember the name of it. So there's not too many of these out there, but you can certainly build your own. We've built our own MQTT home automation network here, and I've done quite a few videos about that on the past. So we're actually looking at that as well today, how we can integrate our existing home automation into Arduino Cloud, and perhaps why we want to do that. As you can see on this diagram, we've got quite a few things going on there. So the things are the kind of contraptions. If I just unplug this one, I've just mocked up very quickly a little thing here. So there's a temperature sensor, humidity sensor, an Arduino Nano ESP32 on a breadboard, and we're going to program this and make this send data up to the cloud. So that's a thing because it has things connected to it. The device is just the ESP32. That's what a device means from an Arduino Cloud perspective. There's the Arduino Cloud itself, which is a cloud service. We'll have a look at how that all works. And there are dashboards. So dashboards are a way to visualize your data and interact with it, either on a mobile phone, desktop, tablet, and so on. And then we have integrations, so you can connect. There aren't too many integrations available just yet because it's quite new, but we can do things like integrate with MQTT, for example, which is my home automation system. Everything's based around Node-RED and MQTT. And behind the scenes, the Arduino Cloud is actually an MQTT service, similar to the Adafruit one, but they have a few more things on top of that, and it's actually embedded within the Arduino IDE and the Arduino ecosystem. So what we're going to create, we're going to create an Internet of Things. We're going to create 2 things. I've got one already here. We're going to actually make one from scratch, unboxing a brand new Arduino Nano ESP32 that was sent. I say that I was sent, I signed up for the cloud service. We'll talk about that in a minute. And as part of that signing up for an annual cloud service, they offered a $1 or €1 Arduino Nano ESP32 as part of that. So I got that and had that sent to me. So that's what I've got today, and we're going to unbox that. So that's the device we're going to be using. The thing that we're going to be creating is this temperature and humidity sensor using a DHT22 sensor. I've got a box full of these sensors There's a few different types of these sensors. There's like DHT11s, I don't know if I can get that to focus, there we go. DHT5 I think it is, DHT22, so we're going to be using these white ones. The difference is how accurate they are and how granular they can detect temperature changes and so on. So that's what we're going to be looking at for the thing that we're going to be creating. We're going to look at some dashboards as well, how to add widgets to a dashboard, create a dashboard in desktop or mobile view, and see how that data can change in real time as we interact with it on a mobile device such as my phone over here. And we're going to integrate this as well with Node-RED, my own home automation system, with the Arduino Cloud, and we can see data coming from my home automation system into the Arduino Cloud and visualizing that on a dashboard. Cool. So let's have a look at devices then, shall we? So the Arduino Nano ESP32 is quite a new board, this one. It's based on the Arduino Nano platform, I should say, family I think they call it. So the layout of the board, the pin sizes, this picture, all that kind of stuff is the same as the original Arduino Nano, which was an 8-bit chip, but this one is a full 32-bit chip. It has Wi-Fi on board. You can see there the U-Blocks chip that they've got there, which is the main processor, and that runs at 240 megahertz, so it's a bit faster than the chip that we normally look at on this channel, which is the Raspberry Pi Pico W. It does have Wi-Fi and Bluetooth on board. It has a bunch of different I/O pins on there as well, so you can see that we've got the usual suspects, got some analog and digital pins. It also does have a RGB LED on there, and they actually break that across 3 different pins, so you can actually, on pin 14, 15 and 16, control the individual colours as individual pins, as if it's separate LEDs that you light up and they combine to make a colour. It's also got UART on there and I2C SPI, and it also has a bunch of memory as well, the usual ROM, SRAM and external flash, so it's got 16 megs of flash, which is plenty to store our files on there, particularly seeing as when we compile programs for this, we tend to do it in the Arduino language, which is based on another language called processing, which in turn was based on C++. So they tend to be very, very compact, but it does take a little while, as you'll see when we compile this, as opposed to, say, MicroPython, where it just runs straight away. Now, they have actually brought out a separate MicroPython environment for the Arduino. We'll have a look at that as well. It's called the Arduino MicroPython Lab. We'll have a look at that in the demo a bit later on. So the pinouts you can see there, I think this is the correct diagram for the ESP32 Nano. I think on the next slide I don't use the correct diagram because I couldn't find one on Fritzing to show me this, but they're all the different pinouts, and the pinouts for the DHT22, this little white thing, it just has 4 pins. Only 3 of the pins are actually used, and we'll look at how to wire that up on this next slide. So this is the one where it's not the correct. It's an Arduino Nano, but it isn't the actual ESP32, but for the purposes of just a diagram and wiring things up, this will work fine. So you can see there we have a number of different pins. We have the voltage and the ground on opposite ends, and then on the pin number 2, that's where we send our data, we receive our data from this. And it's essentially just sending data all the time. It sends it as like a stream of different packets of data, the humidity and the temperature, all in one, and we then have to unpack that, but it's all done in the low-level code by the driver, and we can simply just get the values as often as we want to. So that's how we wire this up, and we're going to create a device essentially by going into the cloud environment and then creating a new device. And what that does is it tells the cloud that there's a new ESP32 that we want to set up. It will then recognize it as an official one. That means we can unlock some features such as over-the-air updates, which means we can, even if the thing's like not connected to our computer but has power and it has connected to a Wi-Fi network, we can actually send it a brand new program to run. So that's really, really cool. So yes, that's the device that we're going to set up. There are other devices supported as well. So we've got third-party devices that use the Arduino language. And then there is any device which can be manually set up, which can run Python and MicroPython, Java, and JavaScript, I should say, not Java, and Node.js. So quite a few different languages are supported there. However, not all the features are supported across all the different devices. So if you want to get the most out of Arduino Cloud, you do have to run the Arduino language on an official Arduino to get the best out of it. And we can generate, the reason I would say you want to do this is you can actually generate sketches for the official Arduino boards within the cloud environment based on the options that you pick. So it does a lot of that work for you, which is pretty cool. It kind of builds a template for you. So next is the thing. So a device is just the microcontroller. The thing is the thing we create with that microcontroller. So things connect a device to a sketch, to a cloud variable. We'll have a look at what cloud variables are in a second, as well as putting in the network credentials. So when we've done MicroPython things in the past, we've created like a secrets.py. We've had the SSID in there and the password for the Wi-Fi. Essentially, that's what that's doing. That's just collecting that on a separate secrets tab, so you can separate that out from your code. And this will also enable the over-the-air updates for later on, because it's already got that Wi-Fi connection. So as long as it doesn't go out of the Wi-Fi network, it should be able to still receive those. And you can see there with a thing, we can associate a specific device to a thing. So we're tying that together to the sketch, so it knows which thing is associated with which device that you own. And you can see all the things that you have registered on there. So what are these cloud variables then? This is quite a cool idea. So a cloud variable is a value that is synced between your Arduino board and the Arduino Internet of Things cloud. So if the variable is changed on your board, so say that there's a sensor that says here's the new temperature, and you grab that on your board, that variable is automatically synced via a built-in function of the Arduino Cloud. We can have a look at the code in a second and see how it actually does that. But in a way, you don't have to worry about that. You use the variable, it updates automatically, and vice versa as well. So if you toggle a switch, for example, on your dashboard, and that is linked to a variable, that variable will change on your board as well. And it's pretty near real time. It's very, very quick and responsive. And that's thanks to MQTT. So if you like what I do and you want me to make more of these types of videos, please give this video a like. Drop me a comment, let me know if you've used any ESP32s in the past, if you've used the Arduino ESP32 or you intend on getting one. And let me know if you prefer C++ over MicroPython. I'm just interested to know, a bit of a poll there. And if you want to subscribe to this channel as well, it means a lot to me if you do that. It helps me grow my numbers, and it's one of the metrics that I can look at and see how the channel is doing. So please subscribe if you can. Okay, I do go live every single Sunday, apart from the last 2 weeks when I was on leave and in the Rome Maker Fair. But yes, every Sunday, 7 o'clock GMT, or British Summer Time. So we're now in GMT, so GMT -0 or +0. Cool. So let's look at dashboards. So dashboards help us visualize data and sync to those cloud variables that we looked at before. So they're driven by those cloud variables. So any widget that we put on there, we have to link to a cloud variable to make it mean something. And the device and the thing that we create have to change those cloud variables for it to be displayed on the dashboard. But the dashboards are pretty flexible. You can store historic data on there, and depending on what cloud plan you pick, so I think there's about 3 different plans at the moment. There's like a free tier, there is a maker tier, and then there's like a professional tier, I think. We'll have a look at those in a minute anyway. So there's different tiers depending on what kind of plan you've got, and they also have how long that data is stored for. So is it stored for like 7 days, a month, or 3 months, I think it might be. We can have a look at the specifics of that shortly. But I've used it here to show the temperature, humidity in my loft in my house, which is coming from my home automation system. That's actually running on, I think, MicroPython. Actually, it might not be on that one because that's so old. That might actually be an Arduino sketch running on an ESP8266, I think it is, with a DHT22 chip as well. So very, very similar to what we're creating today. So that's just sending that data to my MQTT broker, which is just running, I think, on this Raspberry Pi next to me. And that's basically just sending that to anybody that subscribes to it. So I've also got a Node-RED instance which could take those readings from the MQTT broker and then do something with it. So what it does is it sends it to my influx database, and then that's graphed in Grafana. So we can have a look at that in the demo as well. So we've got integrations. So integrations is how we connect to the Internet of Things cloud, the Arduino Cloud, to our home automation system or any other systems that we want to. So we can connect it to something like Node-RED, for example. We just need to have an API key which we can create in the Arduino Cloud, and a secret that it will give you, and it only gives you it the one time. So if you don't copy and paste that correctly, you'll have to just regenerate that key. But that's a way of protecting it and making sure that it's not stored anywhere other than that one time when they give it to you. And this can be used to change or get and set the cloud variables, and it also supports Python, Node, JavaScript connectivity to the Arduino Cloud. So the integrations is quite a cool and a newish feature to the Arduino Cloud. So we're going to use that today as well. And finally, we've got triggers. So triggers are quite simple. They're simply send emails at the moment. I think later on they'll be able to do text messages through SMS, text messaging service. And we simply just create a condition. So the trigger is something like if you switch a switch on the dashboard, that could be a trigger. So therefore you have to have a variable that's a Boolean, true or false. And then based on whether that's true or false, it can trigger the action. The action can be sending an email or notifying people through a rich notification on the app, for example. And that's it. It's as simple as that for triggers. Okay, today we've got a sponsor. We have PCBWay sponsoring the channel today. So I'm just going to play a quick message from them. This video is sponsored by PCBWay, your ultimate destination for all things PCB manufacturing and assembly. Whether you're a hobbyist, a startup or a seasoned professional, PCBWay has got you covered. PCBWay offers an impressive range of services. They provide high quality custom designed printed circuit boards for any application you can imagine, from single layer to multi-layer, flexible and even rigid flex PCBs. They have the expertise to bring your designs to life. PCBWay ensures fast turnaround times and affordable prices without compromising on quality. With their state-of-the-art facilities and advanced manufacturing techniques, they can handle small prototype orders up to large-scale production runs with equal precision and efficiency. PCBWay offers additional value-added services such as PCB assembly, component sourcing, and even functional testing. You can trust them to deliver the fully assembled and tested boards ready for integration into your projects. One of the best parts of PCBWay is their user-friendly online platform. It allows you to easily upload your designs, get instant quotes, and track the progress of your orders in real time. Plus, their dedicated customer support team are ready to assist you with any questions or concerns. So whether you're working on an innovative Internet of Things device, a robotics project, or anything in between, PCBWay is your go-to partner for reliable and affordable PCB manufacturing and assembly. Head over to PCBWay.com today and turn your ideas into reality with PCBWay, your trusted PCB manufacturing and assembly partner. So thanks to PCBWay for sponsoring the channel for today's video. Okay, so let's have a demo of the Arduino Cloud, shall we? So what I'm going to do, I'm just going to pull up a browser so we can start looking at this. So let me start off. Just going to go over to things. Here we go. Okay, so I've got quite a few things, as you can see, registered on here. A whole different types of things as well. So I've got, you can see there, an Adafruit Feather ESP32S3. I have my home automation system. I've created a thing with that. I've got the Arduino Uno R4, which is the one with Wi-Fi. That's currently not working. I seem to have bricked it somehow. I'm sure that will come back to life at some point, but I think I just need to do some special sequences on that to bring it to life, because it actually has two processors on there, one for the Wi-Fi and then the sort of main processor for the board. And there's a little jumper you can connect to switch between them when you boot the thing up. And I think I just need to make it go back to how it should be on there. I don't know what I did, but it's broken. I've got a Node MCU chip, which is a very early ESP12E, I think it is. So it's still a 32-bit processor, but it's quite limited on memory. I've got an Arduino Nano RP2040 Connect, which I think is this box here. So this is the Arduino RP2040 Connect. Very similar to the Arduino Nano ESP32 we're using, but it has the Raspberry Pi RP2040 chip on board. We have some other manually configured devices. I was just trying to see, could I get this working with Python and even MicroPython. It's a bit convoluted. I don't think we'll cover that in today's show, because it's there's quite a few things that you need to do with certificates, downloading those to your file locally and so on to make this work. So, but in Python that does work quite simply actually. And then Weatherbot, which is the one I've just created for today's show, is a brand new Arduino Nano ESP32. So if we go into that particular thing, we can have a look at, we've got two cloud variables there. We've got humidity and we have temperature. These are both floating point numbers, so they're floats. You can see that the last value came through at 708, 708. So if I plug that back into some power, I've currently got it unpowered. And let's see how quickly it connects to my Wi-Fi and then start sending us some new values. So as long as everything's not come out the breadboard, we should be fine on there, and we should see it. It usually takes about 30 seconds, I think, for it to validate with the Wi-Fi and then validate with the MQTT broker, and then the values start coming through. But you can also see on here we've got things like the ID, which is like a unique number just for each particular device. We have the type of device that it is, so you can grab that when it's connecting to it, and whether it's online or offline. So when I pull the plug out of that one just to hold it up to the camera, that's where it lost the connection. But you can see now it's back online. We've just got some values through there a couple of seconds ago, and that status will change to online, I suspect, very shortly. In fact, let's just refresh this page and see if that comes on as online. There we go. So that device is now online. And we've also got on there my Wi-Fi name, my password, my secret key. So that's like the Wi-Fi password, and then there's a secret key for this device as well, which is what it uses to connect to the Arduino Cloud. Now I've got some other tabs up here. We've got sketch and we have metadata. So the sketch is something that the Arduino Cloud will actually create for you when you add a new device in there. And every time you add a new variable, a new cloud variable, it actually adds it to this section here, saying that these are automatically generated, and you can simply just use them in your code straight away. So you don't have to do anything, you don't have to initiate them or anything like that, they're already there. So what I've simply done on this one is I've included the DHT pin, so that's on pin 2, the DHT type, which is DHT22, and then I've just created a variable that's called DHT, using those two parameters. I've also got a toggle which I've used for like an on-off thing, and that's simply just going to allow me to blink a light. So I can just say is the light on or off. So I've just created a toggle variable for that, and that's just a boolean. We have these void setup and void loop in C++ programs. I've also created this blink function here, but if we go back up to the setup one, this runs at the very first time that you run your code. Let me just I was going to move this down, but I think this black area here is actually the console when you're running your code, so that's why that's displayed there. We can actually open up this in the full editor, and I can even send an update to this over the internet, over the wires, using an over-the-air update, and we'll have a play with that in a second or two. So serial.begin simply just sets the baud rate, which is the speed that it's connecting to the serial device, which is the console. We're going to delay that just for a second, just to allow it to set up that UART properly. We then set up the LED so it can blink. So we set the pin mode for the built-in LED to be an output. We then start the DHT. So we basically just sort of say, send it a special command that basically just says this is an initiation, just start sending data through. And then we can use those two cloud variables, humidity and temperature, just by doing DHT read humidity, making that equal that, and DHT read temperature and equal that. I'm not sure why that's orange and that one isn't. I think that's just a quirk of the editor that we're using here. And then this thing properties, which is part of the Arduino Cloud, that gets initiated too. And then the Arduino Cloud.begin, that's the thing that manages all the synchronization behind the scenes and also tells the Arduino Cloud that we're online, as it were. We've then got this debug message level, and then we can Arduino print debug info, and that will print it out to the console if you're connected, and I think it can also connect it to like a cloud one as well for debugging. So the blink code simply just reads the toggle variable. If the toggle is true, it writes a 1. If the toggle is false, it writes a 0. And it will also just flip the value of that. So if it's true, it becomes false. If it's false, it becomes true. So it just toggles that. We don't have any pause in there. We do that in our main code. And then I've got this variable that's called sleep. We then have the Arduino Cloud update. So that's the thing that will synchronize the cloud variables in the background. We then grab the latest humidity and temperature. And the next time it goes round to that Arduino Cloud update, it will update those variables as long as there isn't any delay. And we've got a little delay in there of 1,000 milliseconds, milliseconds I think that is, so essentially 1 second. And then we do a serial.print, which just prints the word humidity and then the humidity value. I've got these on separate lines there, and then print line basically just does a new line at the end of the word temperature, so it just prints it all on one line. Then we do blink, which just makes the LED up that's built in on board, flash, and then we sleep for whatever the value in sleep is, which is just 1,000, so 1 second. And then we've got some placeholder pieces of code here if we want to manually change the Arduino temperature or humidity. So if they get changed from the cloud, we can then react to these rather than us changing them and it being changed, sent up to the cloud. So there's one for each of the different types. I originally had a variable that was called pressure. I'm not actually using that one now, so that's a remnant of that. I thought the original DHT22 could do pressure as well, but it can't. They're the BME 280s, I think, which are a different chip. So this is a cloud-based editor. We can actually click on open in full editor. So you can see there it's got create.arduino.cc editor, my username, and then the thing that we're actually editing. And here's all the different things that we can edit there. And you can see there it's got like an automatically generated README doc. So it created all the stuff that's in there. I created a layout.png, which is that slide that we just saw before, which is just the wiring diagram. They suggest that you do this for anything, so anybody else who wants to use this can do the same. So I've just created that in there. And then we've got things like the thing properties, which is like the ID of the thing. And it grabs from the secret tab, which I will not show you, my SSID and password, and then the device key as well. We can see there it's got like the cloud variables and everything else, and I think this is automatically generated. Yeah, code generated by Arduino Internet of Things Cloud. Do not edit. So there we go. So this main weatherbot.ino is the main file that we edit. So we can actually send that up to our thing. Now I think at the moment it's going to connect, because I've actually physically got this connected to my computer, it's going to send it via the quickest way, which is over the USB cable. So you can see there it just says uploading, and then in this little dark area down here we'll get the messages saying if it's uploaded and if there's any bugs in the code or anything like that. Now this is one of my bugbears about C++. Yes, it's really fast executing speed, but compile time is just really slow. And I'm using a Mac M1, so it's a really fast machine. Shouldn't have any problems compiling code for a microcontroller, but it does seem to take a very long time to do that. So you can see that it's talking about the DFU and claiming USB DFU interface, blah blah blah, copying data from the PC to the DFU device. It takes a surprising amount of time for it to do that. It says it's done, and we've got the green success, everything is good. So we've now got the latest code on there. Now, one of the really cool things, if I actually unplug this, if I go to my overhead, I unplug this from the USB, and I just plug it into some external power. So this is a Raspberry Pi USB connector, I think. There we go. So it's now waiting to connect, and it's now running the code. So let's go back to I'll go back to the browser, and we'll see if we can see this device now on our Internet of Things cloud. The other thing that is a bit of a bugbear is it opens up a new tab every time you click on one of these, so I find that a little bit irritating. Right, anyway, so let's go down to weatherbot. Let's see if this is now online. It does say it's online. Let's see if the values, yep, let's see if that changes in the next couple of seconds. Yeah, there we go. So even though we're actually not connected, if I go over here, you can actually see there that the thing is sending data. It's connected over Wi-Fi. It's grabbing the values from here, and it's sending them up to the cloud via those cloud variables. So that's all working as we would expect it to, which is pretty cool. Cool. Metadata is just a way of tagging your projects, I guess. I don't really see much value in that at the moment. I'm just going to turn that down there. But yeah, so you've got sketch and setup. So that's things. So let's set up a new device. Let's unbox a brand new ESP32, shall we? So I'm just going to grab some scissors, and we can do this on the overhead, because this is literally brand new, and I've not opened this one at all yet. So they have a little bit of sticky tape on there. And if we just open this out, so in the box we get some headers, we get some thank you for choosing the Arduino thing, and we get the board itself, which is just here. So yeah, we've got these header pins. which means it'd be a bit tricky for us to actually build another thing, but we'll give it a go actually, because they're not soldered on. So if I just plug this in like roughly here on this breadboard, it isn't actually soldered on, so depending how good those connections are, it may or may not work the way we expect it to. Right, so what I'm going to do, I'm just going to plug in that into my breadboard, and then I've just got a bunch of wires here, some breadboard wires, and we're just going to plumb this in the way that we need it to. So that is the ground, so that's going to go to the, so one of these has actually got like a little, get this to focus in, this camera honestly, I think it's the white light that stops it from focusing. So you can see there one of the pins has got like a white mark on it, that means that that's the ground. So we can just simply, let's use a different thing that's actually got the right connector on the end, that means we can use that. And if I now use a different one for the power, so that's the red, so the red is pin number 1 there, and this is going to go to the second pin down, more fingers and thumbs here, and then we're going to just choose, which was it, pin number, I think that one there, actually let's go for the same one that we did on the other one, there we go. Right, so that's going to plug into pin number 2 on the DHT22. So there's my breadboard, it's configured exactly the same way as that, but I'm going to plug this one in, and you can see there we've got the LED, and on my Mac it's saying, do you want to connect this accessory? So I'm saying yes. Okay, so that's going to keep cycling around. If I just turn off the lights on the overhead for a second, if I can get this to respond properly, let's try that on there. Of course, my overhead lights don't want to respond when I want to sort of turn them off and show you what's going on there. But essentially there's like an LED there that's just changing colours, green, red, blue, and so on. And that just means it's running the default sketch that's on there. Okay, let's go back over to over to here, and let's add a new device. So now I have got another piece of software that's running in the background. It's actually gone off now, so we can just go back there and just show you that. I don't know why it took so long for it to do that. There's like a second RGB LED there. You've got the power, and you've also got this built-in LED. So this is an extra one that you can do things with. Okay, so let's go back over to here. So I'm going to set up an official Arduino board. It's waiting for the device to become available. So I've got some cloud software that's running, which is like an agent that runs in the taskbar that you can't see on here. If I go to debug console, I think it just opens up a browser page. So yeah, it can actually see that device on there, which is great. So if I go back to the right tab, so it's found an ESP32, we can configure this. So we give it a name, Roxy. I don't know why it's picked a Roxy. So let's call it Roxy Arduino, I don't know, ESP32. Don't know why I capitalised that R there. And let's just go to next. And it's going to give me some secret keys and device keys. So I'm just going to grab these, and I'm just going to save these off to, let me just save these to a note. Let me just grab a new note. So I'm just going to plop that into here. There we go. So that's the device key, and that's for Roxy. So I can regenerate these keys after the show if anybody's worried about my safety there, or if anybody's going to rip that off. Okay, so we're all set, and we've now got a new device on here, which is this Roxy. So we need to create a thing. So we click on the things, and this is where we can create our cloud variable. So let's call this one live stream demo. Let's add a variable. Let's call this one temp. And we want to say that this is a floating point number. So we've got all the different options there. We've got booleans, character strings, floating point numbers, integers, and so on. So I'm just going to have a floating point number for that. And you can say whether it's read-writable. Really, we want this to be read-only because we're going to change it on our device and send the value up to the cloud. We don't want the cloud to change that value and send it back. So really, we should make this one read-only. And then the update policy, so how often do we want this variable to be updated? Is it periodically, so we can specify how many seconds, or is it as soon as it changes? And we can even set a threshold of like how many of these changes should we accept before we stop listening to that, just so it doesn't get overloaded. So I'm just going to create that one, and let's create another one for humidity. So let's just call that one humidity. That's also a floating point number. That's also read only, and we're just going to add that variable. There we go. So we've got our Roxy device is now associated with this thing. We need to add some network credentials, so I need to add in my Wi-Fi username and password. So let it do that. I'm just going to go back to me for a second while I type in my keys, and let's just go back to here. And so it's asking for a secret key down here. So if we go back to that note, that's our secret key for the device. So let's just paste that into there, and then save that. Whatever, let's update that, and that's now associated with all that. So we've now got this sketch that's been updated. So you can see here the humidity and temperature variables that we created. It's created some default code. It isn't actually doing anything with the DHT22. We'd actually have to bring that code in, but what we can do is we can actually upload this code as it is, even though it doesn't really do anything just yet, straight to our board. So because this is compile code, the first thing it has to do is it has to check that the code is valid. So it'll verify the code to make sure there's no bugs in it. It doesn't do this in the editor and bring them up. So the editor it's a good editor for an online editor, but it's not as good as, say, VS Code, which you could use instead to edit your code, and that'll give you hints and tips as you're typing it in and show you where there's likely to be any problems with your code. Like I said, this is one of the reasons I'm not a big fan of C++ for development, is because it takes ages to compile even the simplest code, even on the fastest kind of computer. So this is just something you just have to accept with C++. The actual code running is really, really quick. Now, on a microcontroller, do we really need that kind of speed for doing something like this, where we're just grabbing some temperature readings from a sensor and then sending them up to the cloud? Does that have to run at 400 frames per second? It doesn't. So this is why something like MicroPython I think is far better, because you can edit this and have that quick response time to see if there's any problems with your code. There we go, no problems found. So it's now going to upload it to the device. I think it's done that. There we go, success. So if I now go back to our list of devices, we should now see that one is also online. So Roxy should become online very shortly. Once it's decided to connect. So let me just give that a refresh. I suspect it has connected by now. Let's see. There we go. So Roxy is now online as well. We've got that nice green online button there. Cool. So that's how we do devices. So let's go to dashboards now and create a new dashboard. So let's give this a name. I think I'll call this one like live stream demo or something like that. And I'll just wait for that to do its thing. There we go. So let's call this one live stream demo, and we can add things, widgets, to our dashboard. So let's add a gauge. So this gauge is going to display some value. We can give it a name first of all. So let's call this one temp, and we can then link it to a variable. So you can see all the different things that you have here. So we can find Roxy on there. If we've created a thing, oh, there we go, live demo, sorry, and we can connect that to temperature variable and link it to that. So at the moment we're actually not grabbing any values in there, so let's change that and link it to a different thing. Let's link it to that weatherbot that we created. I created earlier, but essentially doing the same thing. So if I link this variable, we can now see that 21.5 is what it thinks the temperature in here is. And if I just go full screen there for a second, you can see we can do things like show the name on the widget, which just puts the weatherbot title down there. You can hide the frame, which just hides all the other stuff at the top there, which is the name of it. And we can also specify a minimum value and a maximum value. So if we say -10 to +50, so -10 like that, then that gives us a kind of, what do you call it, thermometer. What's the thermostat? That's the word I'm looking for. There we go. So that will show just what the current value is. Now we can also put on here, let's see, a chart. So let's add a chart to this as well. We can link the same variable to that. So if I go down to weatherbot and pick that temperature, link the variable to that, We can also show the name on there. We can also call this one a temp chart. And we can decide whether it's a line or a spline. So if I go for like the last hour, once we've got this connected up, there you go, you can see what the temperature is and so on. Now if we want to change the size of this, we click on, I don't know why it doesn't let you do this without going into this special mode, but you can see there it kind of moves and connects to these little dots, so they're always in line. You don't have to worry about the alignment of things. Things will automatically align. So you can move things around, but they'll always be snapping to these little dots like so. So maybe we want to stretch that one out. So this is currently doing that for the desktop version. If we want to see what this looks like on a mobile device, we can see that how it looks there. Again, we can move this around just for the mobile device. So maybe we want to have that one small in the corner. And then maybe want to move this one up a little bit like that. We can do that. There we go. So we can then see, yeah, 15 days worth of data is what I've got on my plan. And the plans are available up here to click on. Not sure if, so I'm currently on the build yearly. There we go. So these are the different plans that they've currently got. So there's a free one. You can have 2 things, a limited number of dashboards. It will store 100 meg worth of sketches. You've got 1 day of data retention for your data, whatever that data might be, so a temperature for example, 25 days worth of complications, actually not sure what that is, and then machine learning tools is built in as well. The entry level one, which is $1.99 per month, which is pretty cheap, gives you access to the APIs and the over-the-air updates as well, so that's not available in the free tier. And the maker one, you've got 25 things, you've got dashboard sharing, cloud triggers, and then there's the Maker Plus, which is all those things, but you basically got 100 things available to you there. And they've got a little chart there of all the different things you can do with that. I was curious to see what that complications was, but yeah, whatever they are there. Go compilations. I thought it said complications. I was thinking like on an Apple Watch we have these complications. Compilations, it's how often you compile this in the cloud, because obviously they're doing that. Now this thing is worth noting here. They've got this 30% offer for yearly plans for the Maker one. So I went for that Maker tier there, which was $4.20 per month. But if you buy that as a yearly plan, it ends up being about $70, something like that. But if you get 30% off, that lowers it down to $50. And you just need to put in that Cloud Nano 32 offer there. And they then also have a, when you purchase the annual one, you can also buy an ESP32 Nano 32 for $1. So that's worth it just for that alone. I think after that first year, it then goes back up to the full $79, whatever it ends up being. They've got a tier for schools as well, so you can see there how many pupils there are for the school thing, so 5 things per member. And then there's also for business as well, so you've got things like data planes and sketch encoding, fleet management for all your different devices. That's starting from $42 per month for multiples of 50 devices. And it gets pretty expensive. As an individual, that looks expensive, but I guess if you're a business, that's pretty good value for money. So there you go, there's the different tiers that we have and the different plans. If I go back over here and go back to Arduino Cloud, let's open up another tab. We can see that we've got the web editor and we've got the IoT Cloud, which is what we were in before. Opens up another tab. Okay, so let's go back here. So we've looked at dashboards. I'll show the other dashboard I created, which is called Kev Home. So this has got a few more things on it. It's been running a bit longer. And I've got a couple of extra humidity and temperature sensors from my home automation system. I've also got a button here which is called bathroom fan. I can turn that on and off, and that will also make that LED toggle on and off. So although it looks like I'm pressing that and that's going off, because I'm pressing it on this dashboard, there's a lot of stuff going on behind the scenes, and those two widgets are actually not connected. They're connected by a variable which is changing behind the scenes. So again, if we wanted to, look at that full screen, we can click on that. We can click on the mobile view, and we can press escape to come out of that. So quite like these dashboards. I've got the app on my phone as well, so we can change things like, if I go back to the desktop view, let's see if I can do this in real time. So if I go to the Arduino IoT remote, as they call it, I go to Kev Home, And if I find that button that's there, the bathroom fan button, so at the moment this isn't actually turning my fan on and off because it isn't actually switched on there, but if I wait for this to update, just make sure I've got my Wi-Fi turned off to make sure it's definitely connecting. It just says cloud connections failed, try again later, so I'm not sure why that's failing there, but that's particularly unhelpful. If I'm trying to do a live demo, sometimes these things happen. Just refreshing that. There we go. Right, so I've got some data appearing on my phone. So if I toggle that button, let's see what happens on the screen there. So I've toggled that off. It should take a couple of seconds for that to appear on here as being toggled off. So I'm not sure why that's not done it instantaneously, but sometimes it can take a little while for that to happen, particularly seeing as this seems having some issues there. If I just refresh that, maybe it'll fire that off there. Let's try it the other way around. If I click off on there and then on here, does that update on my phone? I think this is more to do with the phone app not being particularly responsive rather than the actual thing being responsive, because I can see these values changing in real time. But this is why I wanted to show you it. Sometimes things are quite responsive, but not necessarily if they're over a cellular network for some reason. But we can actually see the data on there. Cool. So we've looked at dashboards, things. Let's have a look at integrations. So they've got messages just saying go to the Arduino Cloud for integrations, opens up another tab. And we can see I've got two things on here. So this home MQTT, this is one I've created, and this is simply just create API keys. That's all this page does. They've got some courses and resources on how to use this. So if I now go over to my Node-RED setup here, so this is actually running on a Raspberry Pi in a Docker container, so I can fire these up and tear them down as I need to. And I've got on here, if you want to know more about Node-RED, I've done an entire video series on that, so you can check that out. But if I go down to Manage Palette, so I've got the Arduino Node-RED contrib, Arduino IoT Cloud node added, as well as things like the Google Sheets, Philips Hue Magic, which is the Philips Hue home automation stuff, as well as the Node-RED dashboard and InfluxDB nodes. So they're all added to this. And on this debug pane here, which if you click on this little bug, you can see, if I just clear all these out, you'll see there, so the humidity sensor, it says 6.5, and we're getting these 6.4, 6.5. No rounding on that at all. So here's like the full value that the sensor has provided. So what's going on here? Let's have a look. So we have this bathroom fan. If I click on that button there, that will say true has been injected or false has been injected, so I can toggle this on or off, and that will toggle on or off on our dashboard as well, because it's all connected together. And then that value that you can see in the debug, so anything that appears here is basically coming from this debug node, and we've got a whole bunch of things. So loft temperature and loft humidity are the things that this node here is providing. So we look at this. These are the nodes from the Arduino Cloud. So we can see there I've got the home MQTT thing set up. If I go into here, I've got my client ID and my client secret, which were generated from that page where we just create the API keys. That's where we put them into Node-RED. And then it can then query that and see all the different things that we created. So the live stream demo one there, for example, with the humidity and temperature cloud variables that we created a couple of seconds ago. If I go back to the weatherbot, we can then hook that one back up to be, what was it? Was it humidity or was it temperature? It was actually temperature, so let's just go back and change that to be temperature. There we go. Save that and then deploy. So this is running on, like I said, a Raspberry Pi just behind me. One of them flashy lights there is running this node number 3, based on the IP address there. And you can see that I've got a whole bunch of cloud sensors which are putting data, pushing it out to the Arduino Cloud variables. So I've got one there for loft temperature. So I'm getting the loft temperature. I'm also getting rid of all those floating point numbers and basically just having it reduced down to 1 decimal point, which is what that 1 there means. So when I send that out to the Internet of Things cloud loft temperature cloud variable, then it'll just be just 1 fixed decimal point. We've got the other one there, so that's loft temperature, there's the bathroom fan, and then there's the living room temperature. So these are all cloud variables on that thing that I've called Kev's Home. We can also, so they're sending values out because the little infinity symbol is on the right hand side, and then node is taking data in. And there's another one where the data comes in and the data goes out, and the infinity symbol is on the left, and that means that we can actually set a value. So the bathroom fan one there, for example, is just toggling on the home MQTT thing, the bathroom fan variable, which is just true or false. And we can see there we can actually set that variable, even though it's being sent to the debug there. We can set that just by pressing these injection things, or true or false, and as I do that, they'll be sent through and toggled. So that's something that we can actually see there. Okay, so if I just delete all those messages and just do a true and a false, let's just see if that comes through. True and false. I'm just looking to see if the debug message appeared on there, but maybe I've not got that set up quite right. Okay, and then on here, this home Sonoff fan is the actual device in my bathroom that turns the fan on or off. I did this so that I could have the fan come on during like normal working or waking hours, I should say. Whereas if you go to the bathroom in the middle of the night, the fan doesn't come on and make a load of noise and wake people up. So you can do that with the fun of home automation. So I've got a couple of other tabs in here as well. I've got a whole bunch of Enviro sensors, which are for the Pimoroni Enviro thing. We've got the BurgerBot controls for controlling my robots. There's the one that we built in the live stream. We've got the 3D printer. So I've got 2 3D printers, and it can grab the status of them. We can do something. We could build a thing that would show what the status of our 3D printers currently is because of that. We've got things like the Enviro hat. So this is a whole bunch of temperature and weather settings. So if I go to 300, I think it is, on IP3, we can have a look at my Grafana setup, which has all my weather station stuff on here. So we can look at things like the dew point, the wind speed. Interestingly, noxious gases are going up. That's because in the UK on the 5th of November, which is today, it's bonfire night. So we celebrate the fact that the Houses of Parliament wasn't blown up by Guy Fawkes by setting loads of fireworks off, ironically. But this is interesting. So the loft and the summer house temperatures, the living room temperatures, these are all from different sensors on various different microcontrollers. So I think the loft one is an ESP8266 with a DHT22 sensor attached to it, running some Arduino code, and that's telling me it's 14.6 degrees in the loft. The summer house, that's probably about 2 or 3 degrees higher than it actually is in here, because I've got my air conditioning which says it's set to 18 degrees, and there is also another sensor behind me that says it's about 22, so 23.4 is a tiny bit out. And that's down to how accurate these little sensors are. And similarly, got a living room one, which is just next to my couch in the living room. I think that's a Pimoroni Enviro Plus hat for the Raspberry Pi Pico W. And we've also got humidity sensors in there too. The wind speed is coming from a anemometer, which is on the side of my summer house, just outside the robot lab. And all this data can be exposed to the Arduino Cloud via cloud variables via that integration with Node-RED. So I can simply just grab, by using one of these MQTT in, I can grab, let's go down to the bottom here, a property that we want to connect that to, and then I can just configure that in here and just find the subscription, such as what would it be, home temp, I don't know, loft or something like that, and then connect that to a property which is like a thing. So we'd click on here, the weatherbot, or no, let's say the live stream demo, and I could, now there's no writable properties available because we set them to read only, if you remember, but we could also go back to the home MQTT one, and we could set, I don't know, the loft temperature there, so that can feed into that. So any variables that change in my home automation system can then fire that up to the thing, which is Kev's home MQTT. I didn't deploy that, so that actually hasn't happened. You have to hit the deploy button to actually make that code real and live. There we go. So that's how we connect things using integrations. Okay, I think that's everything I wanted to cover off on the cloud things. Let me just have a quick look at my notes on there. So yes, what does it actually work with? So one of the things I wanted to sort of cover off with was which devices does this actually work with. I was just going to go to my overhead thing, but my light's currently off on there, so it'll just have to be in the dark. So obviously the new boards like the ESP32, the RP2040 Connect, the Arduino R4 Wi-Fi board, they all work. The original Arduino, which is the Uno, this one won't work because this is only an 8-bit processor and doesn't have Wi-Fi, so we can't use that. But we can use things like the Raspberry Pi Pico W. That's completely compatible, as well as things like the Wemos D1 Mini, any ESP32 type board, and a lot of the Arduino boards from Adafruit as well. So they're the ones that are supported. The Arduino Nano, the Mega, the original ones, they're not supported. And when I say supported, just the cloud element of that, you can use the cloud editor to edit code for an original Arduino as long as you've got the correct cables and it's connected to your laptop using the cloud agent. I think they call it the create agent. So as long as you've got that installed, that can do the bridge between your serial device, your browser, and the cloud editor. Cool. So that's the. So I did want to show you one more thing on the demo actually, which is how we can change a value and do an over-the-air update. So if I go back over to this very dark looking thing here, this thing here is my weatherbot, which it isn't connected to my computer. This white cable is connected, this one isn't. So we can change a value on here and have that flashing light there that's flashing about once every second. I think it's once on, once off. We can toggle that and change that to be a value of our choosing. So I'm going to go back over to my editor over here. Let's just find the one that's got the correct thing on it, and let's change that sleep variable to be something other than 1 second. So I'm going to make it really quick, so 1/4 of a second. So if I do that and I do upload, let's see what happens. You can also see on here it's got loft has been disconnected, and you'll see those occasionally come in. They're really old Arduino sketches that do have cloud over-the-air updates available to them, just because they were compiled when that software was available, and therefore they can present themselves and be written to over the Wi-Fi, which is pretty cool. So they'll just appear every now and again. There's another one there. There's one for the fan and one for the heated mirror in the bathroom. So they're both separate devices. I think they're actually Sonoff devices. I'm not sure if I've got one of those to hand. I used to have one just next to me, but I don't think I've got that anymore. But yeah, Sonoff devices. No, I've got that to hand. Right, so there we go. It says it's verified it. I think it's now doing the update over the air. So we should see in a second. If I go to this view here, you can see that it stopped flashing as it's receiving the over-the-air update. So that's a good sign that that's working. And once we've got that nice green success message there, we should also see that that LED will start flashing a couple of times a second. I think it's 4 times a second. So yeah, 250 is like 1 second divided by 4, isn't it? So once that has decided to complete and verify, then we'll be good to go. I don't know what the maximum size of the code you can send over the air is, but I've not come across any of those things yet. There we go. So that's now completed. We can actually see the LEDs flashing 4 times per second. Was that twice per second? And then we get the success message. So it's verified that everything's great. And it's come back online as well. So that's how we do over-the-air updates just using a browser. So this is just a browser-based editor. and we can do that without having to have the thing connected to us, to our laptop directly. So that's pretty cool. Cool. So let me just go back to my slides. I think there's just a couple more things to cover off. We've not announced who the winners are of the giveaway from 2 weeks ago, so we need to cover that off. But before we do that, I just need to cover off a couple of things first. So if you haven't checked out the learning platform, I've got loads of free courses available to you. There's no sign up or anything like that. You can just dive straight into the learning materials. Just go to kevrobots.com/learn/ and you can pick any of the free courses there and get started learning MicroPython today. And robotics and all kinds of other stuff, 3D printing and so on. We also got merch, so you can buy one of these great hats, or mugs, or hoodies, or t-shirts. So I had a great time in the Rome Maker Fair wearing my Kez Robots t-shirt. I had the Bubo one and also the BurgerBot t-shirt in bright red, so people could recognise me, and I was very on brand. You can go to kezrobots.com/merch to check out our merch there and support the show. And we also have a Discord server. So if you've not joined our Discord server, you're missing out on a great community. I was just looking through today, actually, and people helping each other with their code, which is exactly what I wanted to happen in the Discord community. So yeah, go to kezrobots.com/discord to get a sign-up link today. Again, completely free, and join the community. If you want to follow me on social media, then I'm all over social media. So I'm on Threads at kevinmcaleer@threads.net. I'm on TikTok at kevinmcaleer6. I'm on Instagram at Kevin McAleer. I'm on X, should change this slide really, at Kev's Mac, and I'm also on Mastodon at Kev's Mac, Mastodon Social. I'm also on Blue Sky as well. I think that's Kev's Mac at bluesky.app, whatever the bluesky.net, whatever the Blue Sky thing is there. And if you want to get your name on the credits, you can do that by buying me a coffee. Go to kezrobots.com/coffee to get the details for that. And if you want to do that, if you want to get your name up on the screen as well as a new subscriber, I shall just make sure we've got these stream elements enabled, which we have. So if you subscribe while I'm doing this, you'll see your name pop up on there. You do a super chat or a super thanks, that will also display on the live stream too. You can also join the YouTube membership program just by clicking the join button at the bottom of the main window, and you can join for the price of a coffee per month. So I just want to give a shout out to our supporters who've already done that, and they've got their name up in lights over here. So we've got Marie-Louise Mayer, who joined recently. We've got Paul Hallam as well. He bought a coffee recently, as well as Marie. And we've got Adam Sargent, we've got Jeff Johnson, we have Dean Corty, Marlene Brent, Tom Shemmy, Steve Phillips. And on our YouTube, the wrong hands here. And then on our YouTube we have memberships. We've got Chris, we've got Cassie, we've got Dale, Tinkering Rocks, we've got JDM, Johnny Bates, Bill Hoy, Oxrag39, Cheerlights, so that's Hans from Cheerlights, we've got Michael, and of course Tom. So thank you for helping support the show. You can get your name, as it says down here, by either going to kezrobots.com/coffee or kezrobots.com/credits. It's the same link. Great, I think that's everything I wanted to cover off there. Yes, it is. So we have some winners to announce for the book giveaway. So 2 weeks ago, Danny Staple came on the show, and he was giving away 2 copies of his brand new book, which is all about learning Raspberry Pi Picos and robotics on Raspberry Pi Picos. So he picked a couple of people on there. So let me just bring that up on my other screen so I can tell you who it is. So one of the question was, what are your favourite... Alex can help me with this one. What are your favourite Halloween projects?
Oh, it's what? Suggest a Halloween project.
Yeah, suggest a Halloween project. So the 2 that Danny picked was the VM Jack-o'-lantern project. So Jonathan Hendricks was the winner for that one. And there's also a 3D printed pumpkin with sweets that drop out, and that was from Wayne Taylor. So Wayne and Jonathan, you'll be being contacted by the publisher who can get your details so they can send you that free copy of the book. So congrats to you two, and thanks Danny for being involved in that and creating the giveaway. It was great for that. Cool. So this is the point in the video where I'll say thank you so much for watching, and I shall see you next time.